Okay. Hey guys. I hope you're caffeinated and ready for this last session. My name is Jørgen Abrahamsen.
And I am Trond Smaavik. And we're here today to talk about open data and intelligent transport systems. This is a topic we've been working on for a couple of years. We're really looking forward to sharing some experiences with you. We work in a company called Acando, which we're located in Trondheim, but we also have a department here in Oslo, and we focus a bit on these subjects. So, let's take a look at today's agenda.
Yeah, so we're going to take a look at open data and explain a little bit about what it is and in the context of Norway.
Mm-hmm. Then we're going to look at intelligent transport systems and use that as our domain here today and see what's the status today and what's the development.
And then we're going to take a closer look at the different data sets, again in the context of Norway. And
of course, we want you to start working with open data, and we're going to show you how to get started with a couple of data sets.
Yeah, and lastly, I would like to show you a project from vegvesen, or the National Public Roads Administration, that has been published as a beta earlier this year.
Okay, so let's start with some vague definitions, because the point here isn't to be legally correct, but to set some terms in place. Open data is data that has been made available by the rights holder under an open license so that it's free for anyone to use. Public data is another term that's been used sometime and in the same context, because data from the government and the municipalities is quite common and to share. And it's also the case that a lot of this data is in practice already financed by the public and therefore should be publicly available. A lot of this data is collected as part of their daily work and not intentionally collected for sharing, but it has many potential uses. In Norway, it's also the case that there's a law that tells us that we have the right to see what data the government has, and it also gives us access to this data and exports of it. Of course, there are some exceptions. It could be sensitive personal data, such as health information. It could be confidential information, such as business secrets, or classified information due to national security. Or there could be data that is controlled by or used by one organization, but it's owned by someone else, so they don't have the rights to share it. So why do we even bother with open data, and what's in it for me? The perspective here I'm going to take is from two different sides. It's both as a data owner and as a data consumer. And you might ask yourself, why do people come to conferences to speak? And I guess there's many reasons, but one of them is that sharing knowledge makes us all better. And the same applies to open data. And even if you share data because you really like the concept and the idea of openness, or because you have to, because the law tells you, the effects are more or less the same. We've seen that sharing data increases innovation, both within the organization that shares the data and outside, because it makes people think differently. Within the organization, people see that collaborating is a good thing, and there may be data sets that one department has never known existed before, but they can make really good use of. And you also end up with better data quality, because when you share data with others, people would find errors, and if there's one thing people like, it's commenting on others' errors. So you're pretty sure that you'll get feedback from the users. And in many cases, this is data that you rely on in your daily business, so it's good to get that kind of feedback. It also is good for your reputation as an organization, because people like when people share. As a data consumer, you could just do it for fun. Just be a real geek and dig down in all the data there is. And there's a lot of fascinating data, as we'll see later on in this talk. Another point is the aspect of transparency and democracy. Because we don't like people who lie or people with power that misuse it. So when municipalities share data about how much money they spend on schools in your area, or how much money they give to different organizations, whether it's sports clubs or whatever it is, it's creating an open and a trustful atmosphere. And of course, it's good for new business. One of the first projects that I was on when I was finished at university was being part of a small team creating a search plugin for oil and gas application. And there we added a data set from the Norwegian Petroleum Directorate as a data source, and it added great value both to the users of the application and, of course, to the client selling it. So there's many good business opportunities in using open data, and I hope you find good sources to look at. Openness is only the first step, because once the data set is online and under an open license, there's only so much you can do if you can't really make good use of it. Tim Berners-Lee, the guy who invented the World Wide Web, has been working on open data for some time after that. And he's made a classification of the quality of open data. The first one I've already mentioned. The second one is about publishing data in a machine-readable format. And that means instead of publishing a table with data within a PDF, you should use a spreadsheet, for instance, from Excel. On the other hand, if you choose Excel, then someone would have to have a special kind of software, a spreadsheet program, or preferably Excel maybe, to read that. So if you, instead of Excel, choose to publish comma-separate values, then you're at level 3, because you have a non-proprietary format that doesn't require you to have special software or pay special fees. So we see that the first 3 levels are quite easy to achieve. When we get to level 4, it's starting to get more interesting too, because now we start adding semantics to the data. And semantics is about meaning, the meaning of data. And that's really, really powerful, because what you do with a number of 11 digits, if you don't know what it is, if you happen to know that this data, this 11 digits, is a social security number, you could use that as a key to look up other data sets and find more information that you could link. So semantics is about relating data to real-world objects. If you really want to please the founder of the internet, you should always also link data. Linking data means that you have, say I have a data set about a book. I know that the book has a title, it's got 350 pages, and there's an author. So instead of just typing in the name of the author, I link to another data set about the author, because I know that some other guy has created that. Say it's William Shakespeare or whoever. So by doing that, we end up with a graph of data that can be navigated based on such relations. And To do this, we use technology called RDF. RDF is short for Resource Description Framework, and it's a method of relating data objects to each other. So this is maybe like Facebook of everything, not just people and organizations, but everything can be related from, let's say, take Bob here. He is the subject, and he is interested in an object, the Mona Lisa. So all statements are built up in this way. A subject with a relation called a predicate and an object. Such predicates are statements that can be true. And in this case, Bob is interested in the Mona Lisa. We can also see that Bob is a friend of Alice, which is another statement. So this is sort of Bob's world, and this is an image of the real world. And let's hope for Bob that there's more to it. So let's take a look at the model world. We see that the subject and objects are the same. If you have particularly bright eyes, you'll see that the object has also gotten an identifier written in small letters below them. So every object or subject gets a URI that identifies them. It's not necessarily a URL as a link to a web page, but it's a URI as an identifier that identifies Bob. This is Bob. He is identified by http://example.org bob-me. And we see that the links have also changed a bit. If we would take a look at the right side first, in the green, we see we have DC terms creator and DC terms title, and DC terms subject. DC terms is short for Dublin Core terms, which is a vocabulary that originates from the library world. So we use these properties to describe things that we normally would find in the library world: books, movies, documents, and we describe the objects by using them. We see that on the blue side we have, for instance, FOF, topic interest, or FOF knows. FOF is short for friend of a friend, and is another vocabulary that's used for showing relationships between people and how they interact. And the strength in RDF really lies in reuse of such vocabularies, so that when I have one graph that is described by using the terms from Dublin Core, like creator and title, I can know that this title means title in the same way that it does in another graph, and knows means that Bob knows Alice in the same way that Leonardo da Vinci knows another guy. And there's also a way to navigate such graphs in a machine-oriented way. There's a query language called Sparkle that you can use. So, for instance, I could look up other objects created by the creator of Mona Lisa, because Bob might be interested in that too. So this is a way to really expand into to linked open data, and this is the way the world's moving slowly. All right, so let's take a look at ITS, which is today's domain. Intelligent transport systems is about making transport safer, more efficient, and cleaner by using new technology and IT. Many of the solutions we see here have been around for at least 20 years, and I'm pretty sure that many of you would be able to come up at least with 10 different solutions that's within the ITS domain, but maybe you haven't necessarily thought about it as a separate domain. But this is a domain in growth. There are different ways of categorizing ITS solutions, and we could start by looking at the one in the middle, a logo you might recognize, the AutoPass logo. This is a typical back-end system that helps with the sort of administrative parts of it, of ITS. Instead of having people sitting in toll booths, you have these toll stations where you can just drive through and you read the chip in the car, or you do digital image analysis of the number plates. That could be one ITS solution. Another solution that doesn't exist yet is the one that we have on the right side. This is from a research project between Volvo Cars and the National Roads Administration in Norway, and where they're trying to use sensors in the cars to predict or to warn other cars around if it's slippery on the roads. You have a lot of sensors, for instance, for ABS brakes. You have anti-spin control and things like that. And when these sensors in the car reach a certain threshold, you can warn other cars that's saying that a kilometer ahead there's ice on the road, so you better be careful. You can also send a message to the road maintainers so that they can come with a truck and remove the ice and snow, making the road safe again. On the left-hand side, we have a guy standing in front of a bus, and that's an autonomous bus, and the guy in front is our sales manager for ITS, Olav. And he's working on deploying such autonomous buses in the city of Kongsberg here in Norway, which happens to be the city with the highest density of engineers. So there's no coincidence he's there, I guess. We've also seen a lot of other companies working on autonomous cars lately. At least, well, actually, every car company is working on that at the moment. So a lot of exciting things going on there too. The last logo I have here is a consumer-oriented ITS service. It's an app called Waze. Let's say that Jørgen and I are driving in separate cars to the same destination, and we want the quickest route. Instead of just sending us in the same direction, Waze might send us on different routes, because Waze recognizes that if everyone goes the same route, we'll all get stuck in traffic. So it's using different routes to sort of load balance the road network. All right, I think that's a good introduction to both open data and ITS. So let's get started looking at some examples.
Yeah, great introduction there, Trond. I think we should look at some specific examples. So there's a lot of Norwegian open ITS data available. The major player there is NPRA or vegvesen. But there's also a lot of other organizations that publish their data openly. So we thought we should take a look. We've picked out 3 sources that we think is giving great value to the end user using it, either as a developer or as the end user viewing it or using it. They are in increasing. We're going to present them in increasing difficulty order. So we're starting with an easy one, and then we're going to increase the difficulty by how to get started with them. I would like to apologize for the selection. They are Norwegian, and most of them are unfortunately only documented in Norwegian. So if any of the developers or maintainers of these projects are watching this video or live here right now, I would urge you to add some English documentation. So yeah, Trond, let's start with the easiest one.
Yeah, let's take a look at Avinor flight information. Avinor is a Norwegian organization that runs most of the airports and flight control. and it's a quite simple service, to get started with flight information. From this service, you can get every flight on the Avinor-controlled airports and under their flight control with an airline code, the flight number, its scheduled time, whether it's a domestic or international flight, if it's an arrival or departure, to or from which airport, and these are the mandatory fields. You might also get fields like via airport if it's several stops, departure gates or baggage belts if it's an arrival, and the status code and time. Status codes can be this flight has been delayed or it's been cancelled, and or it's gotten a new time. They also provide us with some code lists. There's airport codes and names. There's airline codes and names. Unfortunately, these are available only in Norwegian. So, if I'm interested in the airport at the capital of Denmark, Copenhagen, when I ask for the code list, for the name, I'll get København, which is the Norwegian and Danish name of it. But status codes and texts are available in both Norwegian and English. Yeah, let's take a more technical look at it also.
Yeah. So here you have the documentation page. It's as I mentioned, this one is also in Norwegian. The documentation is in Norwegian. The API is implemented with using English language. But as Trond said, if you are going to look at the code list for airports, you will get the Norwegian display name, like København. This is an easy API to get started with. I would suggest, if you haven't played around with any API before, this is the excellent starting point. If you've ever been out flying, as I presume everyone here has, you've seen the info boards at the airport where you have flight times, gates, everything, and that's basically powered by this API. So here are the endpoints. The three bottom endpoints are the code lists, and the top one is the one for querying the API. So I was going to show you some API calls. I used the Postman API client here. You'll get it from Chrome or Chrome App Store, or I think it's ported to Firefox, and it's also a standalone app for Mac. So I have it on a separate screen, so I'll try to show you. So here's if you can see this, I'm not sure if you can read it, but yeah, it's pretty small. But I'll try to execute this, and you see that you get the code list for airlines. If I want to, for example, query for a specific airline, I need to look up from the flight data, which will just show you the code. I need to specify airline, and then, for example, SK, which is SAS, our Scandinavian airline. It's important to remember that this service is case sensitive, so if I type SK with lowercase letter, I wouldn't get any answer, as you'll see here now. Yeah. So retrieving the important or more interesting information is done by doing the query to the XML feed here. You'll see here you can use several parameters to filter your query. So here I have a pre-filled query with the time, I think it's time from, which means that I want to have flights for 1 hour back from now, and 2 hours forward in time. I'm interested in flights for Oslo, and I'm interested in the arrivals. And I want every flight updated after some date here. So I'll just go ahead and execute that. And here you see all the flight data. It's XML based, and you can't get it in JSON. It's only in XML. But here you see all the flights. Each flight has a unique ID. You have the flight ID also, domestic or international. Funny thing here, that is the S, which isn't documented in the code list, but it's Schengen. So it's a special case there. And then we have its scheduled time. And the definition of it, if it's arrival or departure, I filtered for arrivals, so it's arrivals. It's going to...
Gothenburg, I guess.
It came from Gothenburg.
Let's check.
Let's check that. Yeah. So then we have to go to the code list for airports. I need to add a parameter. Airport. Was it GOT?
GOT.
GOT.
Yes.
Yeah, correct. 10 points.
Be a geek about data. This is what I'm talking about.
Okay, so yeah. I think I skipped this list here. Airline? No, I overwritten it. Here. So yeah. Let's get back to this list. Yeah. So here you see, since last query, I now have new information on the top. So this list or this information is always updated, especially on Oslo Gardermoen, which is a pretty busy airfield. Yeah, and the last thing I wanted to show you was down here you have a status which is updated if anything happens. Here the status code A means arrived, yeah. So it's an update time for confirming when the plane arrived. It might be before scheduled time or after scheduled time and so forth. So a challenge for you, if you want to play around with this, is actually collecting data for, let's say, Gardermoen for a month and then calculate the timeliness for each airline. That could be cool. So yeah, this is a brief view of the API. Okay.
Yeah, let's get down to earth again and look at some road data. As we already mentioned, the Norwegian Public Road Authority publishes a lot of data. And I'd like to categorize them into three different types. There's registry data, there's static road data, and there's dynamic data, road data. There's also statistics, but we won't be covering that now. So let's start with the registry data. The reason I call this dug down gold is that there's a lot of interesting data sets here, but there aren't all that many good services available to get a hold of the data. But remember that you can always get access to the data if you ask, unless it's covered by some of the restrictions earlier mentioned. Let's say that I want to buy a used car, and to me, as a car buyer, it would be really interesting to know what type of errors that has been reported to that car when it's been through periodic vehicle control, or EU control, as we call it in Norway. Of course, there's a registry for that. So if I could look up that kind of information, and maybe, in addition, maybe connected with the garage registry, I could see that all the errors that have been reported have been fixed at a certified garage. Unfortunately, that's not possible, at least from any services at the moment. But it would be fine. Would be fun if such a service were to come in place. And it would be easier to sell cars also, because even though you look like the sleazy guy that's trying to sell you a used car, and you might just point at the service, say, I'm telling you the truth, this is a good car. Yeah, that's one example. Say I wanted to learn how to drive a bus. Then I could use the driving school registry to look up what kind or what driving schools in my area could teach me that, because they don't have the competence, all of them, to learn me how to drive a bus. And there's other kind of registries too that are a bit dug down at the moment. But there's actually one little detail here that's showing that there is progress, because the garage registry is now available. It's not available as a service, but it's available as a downloadable comma-separated file. So there you'll find all the garages and their addresses, what kind of certification they have, what repairs are allowed to do. Moving on to some static road data. The Norwegian National Road Data Bank is really gold. It's originally created to make planning of maintenance of roads easier, but there's a lot of more information here. In theory, every road longer than 50 meters that's drivable should be in here. And there's 370 different types of road objects. There's 725,000 road signs, 200 toll stations, and 240,000 kilometers of speed limits. On the left-hand side, you'll find some of the objects that you typically might want to look for: bridges, tunnels, road signs. Even every light post is in here. There are speed limits, and that's not just signs, but it's the speed limits for every road segment. Rest areas along the roads, toll road, landslides and accidents. And there's even information about, very detailed information about the road, sort of each segment, how their length, how they connected to other road segments, the width of the road, height restrictions, load capacity, which is relevant for heavy trucks, and turning restrictions, which is indicating, for instance, if a street is one way, you can't drive in this from this direction. Actually, this information is also published as a separate data set, and is being used by manufacturers of navigation systems. So if you want to create your own navigation systems, you could actually just download the data and get going. This data is updated several times a year, so if you have a GPS and you want to create a map service and a route planner and things like that, everything's set for you. And there's also some of the less obvious data, for instance, wildlife and vegetation along the roads. It could be rare species of flowers and things like that, or it could be a deer crossing. And it also contains geographical areas and administrative areas. It could be nice to know about. So let's take a look at the API again.
Yeah. As Trond mentioned here, the data catalog is large. So I would suggest that you get to know the data catalog and all its different objects, because that will make it easier to know what to expect for the result and what you could actually get out of it. This documentation is in Norwegian again. Sorry about that. Perhaps Google Translate can help you. But in essence, it's all in Norwegian. Also, the implementation of the API is in Norwegian, and the API endpoints are It could return both JSON and XML, which is very nice. I prefer JSON, and it's also the default return format. Yeah, so here you can see the endpoints. All of these are detailed lookup endpoints for the objects in the database, and you use the search endpoint, which in Norwegian is called søk, so you have that in the middle, and that makes it possible to search amongst all the objects in the database and filter on properties and so forth and so forth. The search object is pretty, it's pretty complex. So they've implemented it using a JSON object which contains several filters and limiters for area and, as I said, properties and stuff. So the best way to get to know the envdb is basically to visit vegkart.no, which is what I call a envdb browser. So I thought I was going to show you a little bit about that. There. So here you have vegkart.no, which is a map, and a search box here at the upper right. Let's start with limiting our search for Oslo. And you see that you get autocomplete. And so I picked Oslo municipality. You get a focused area here. So let's run a quick demo of searching for tunnels. Again, we get autocomplete. You have a heading which tells you what kind of object this is. It's an object type. And we click it, and we get a result of 19 tunnels. So if I would first, I would like to look at some of these elements. So we click this list and get a detailed view of the information for this given tunnel. So that's cool. But let's say I want to filter this result further. What I do then is click plus. So let's say I want to search for a subsea tunnel. How many of that type is there in Oslo municipality? So in Norwegian, that is undersjøisk. Yeah. So I select that. So this is kind of a query. So you have to kind of select operator. So it's equals and yes, and hit enter. And then it has returned one hit, so that's nice. So you have also the list here, and you have it marked on the map here. So if you click that, you get information. So this is the operasjonal, pretty new one. It's almost 6 kilometers long, and you have a lot of other information. As you can see down below here. The object contains several child objects and several properties. So the answer you get through the API gives you a list of these objects and properties which you can further navigate to, which is shown here. So we could just pick one and it will show you the information. So it's very verbose, very complete information you get when you search like this. You could of course filter this even more. So that was a quick look at the vegvesen service. But before I leave it, I need to show you the core feature which I wanted to show is this button here. So if I was a developer, which I am, I would like to know how this API call is constructed. or even get the data raw out. So what you do is click this button here, and here you get the choice of Excel, CSV, or even the API call. So I'm interested in the API call. So what this does is basically send you to the page or to the API with the search object pre-filled. And here you have the results in XML. As you can see, it's pretty big. I wouldn't recommend pushing this to a web client, but yeah, I'll give you some tips afterwards on how to handle this. So yeah, you saw this picture. The API endpoint is like this. You paste this search object. Printing it in editor, it would look like something like this. You can see that I've filtered on the municipality 301. I've selected the tunnel type objects, which has the ID of 581, and I also applied a filter for subsea tunnels equals yes. So yeah, the documentation is good in Norwegian, but unfortunately lacking in English. So if you could try to use Google Translate or try to make sense of it, it would help you along the way.
Yeah. Now we've looked at registered data, we've been looking at static data, and now let's move on to dynamic road data. There is a solution and a standard called DATEX2. It's a traffic information exchange format, and it's a European format. So this isn't available only for Norwegian roads, but also it's a service being published by other countries in Europe. Because of that, and because of it's a big standard, there's differences between what they publish. But these 4 points are what is being published in the Norwegian one. Travel times is best explained by looking at the backdrop here. Along the roads you might see signs like this telling you that from this point on you might expect to use 7 minutes to get to Asker or 23 minutes to get to Drammen. And this is data that's dynamically updated based on the traffic and how long it actually takes to get from one point to another at the current time. You also got weather data from weather stations along the roads. They can tell you, it's not just giving you a forecast, but it's giving you actual situation at the moment. The temperature of the road, whether it's any rain coming down. Let's say it's you can see the temperature in the road is below 0, and you know it's going to rain. Then you might expect ice, and that could be nice to know if you're driving there, and it's nice to know for the ones who maintain the road. Road cameras are located usually with the weather stations, and they give you actual pictures of the road and the traffic situation. So you can see that, okay, there's a lot of traffic at the moment, for instance, or you can see that there's snow on the road. Could be nice to know. But the most important one, I think, is traffic announcements. These are announcements that tell you when there's been an accident, maybe a lane is closed or a tunnel is closed for maintenance, and there's information about the reason for the closing, for instance, or how long it will be closed. There could be in the future, say you're planning to drive tonight somewhere, and you can see that this tunnel is closed tonight from 22 till 6 in the morning, and then you have to plan ahead and reroute yourself. And this data and this service is actually being used by Google and Apple also in their roadmaps. So when you in Google Maps see whether it's a red or green line on a road indicating traffic, that's based on this information. As I said, it's a European standard, so you might find other services also. It's XML based, so it's straightforward format, and it's possible to find other services from European. But Jørgen, tell us a bit about what's the situation in Norway. How do we get access to this data?
Yeah. So the data source from vegvesen or NPRA isn't publicly available. So you can get access, but you need to apply for it. So all the people that apply for it often get access. So it shouldn't be really a problem. But you need to actually have a username and password to access the XML. So this service is different from the two previous because they aren't published as a service. They are published as several XML files. You need to actually download and parse these files. The documentation, even though it's also in English, isn't good. But the data is excellent. You can use this for many purposes, and it's recommended to have a look. The datasets data model is documented on the EU site, datex2.eu. So you can take a look at the model there and how it all connects. But here you see the endpoints that vegvesen or NPRA publishes for us. You have the two first ones that are weather data, and the next one, which is the webcam data. And you have travel times, and the last one, maybe the most important one, the traffic announcements for the current state. What you should do is build a parser which parses these files, and then you can put them into your own store. And you can choose how many properties and objects you want to store, because again, this is pretty verbose data. So building your own parser could be a good way to go. But they do support a header called if modified since, so you could pass in a date and time. So if you're polling several times an hour, you will pass in if modified since last time you polled, and this server will answer with a HTTP code for yes or no. You get the answer with XML if it's modified, and a 302, I think, if it's not modified since that. So that's kind of a optimization. It's important to know that these files are updated every time new data. For example, one of the several hundred web cameras in this list are updated. So you have to keep track of what element in this total length of an XML is changed. So that's kind of the downside of it. You need to roll your own diff on this XML. And it's kind of big XML, so this one is not meant for dropping right to the client. You need to parse it yourself and publish maybe your own API. So that brings me over to the next point, which is making your own API. I won't talk about how to make your own API, because that's not why we're here, but I want to talk a little bit about when you should think about or consider making your own API. So we talked about datasets, which is basically XML files and not a service. So since there's not any service publicly available here, you you are pretty much forced to build your own API and data storage for them. And then I think I want to say about datasets, they are momentarily information real time, so they don't have any history. If you want any history with that data, you have to store them yourself. So just be aware of that. Another scenario where you should consider your own API is like envdb, which is pretty verbose when you return the data. Just pick out the data points that you need and expose them into your own API for your client and your use. Then we have the situation where you have several sources that you want to combine into one query and one answer. Could be place search. You have several sources of search for places, like addresses and places. So you want to mash them up into one answer and one call to from your own service. So your service, when a client calls your service calls to other APIs. And when you receive both answers, you answer your client with one mashed up answer. And the last case is when your service, the service you want to use, is password protected and or rate limited. So several APIs, in order to guard themselves against DDoS or that sort of thing, they protect the service with rate limiting and or password. Yeah. So the last thing I wanted to talk about is this map-based traffic information project, which I participated in at NPRA or vegvesen. Initiated and started the last spring. So we started with the idea that vegvesen had a need for displaying their traffic announcements in a better way. The traffic announcements was published in text, and it's not very easy for the person going out in the traffic, the road user that wanted the information about the traffic situation and the way he was going, to see if there was any road work or accidents or anything. So there was a great need for a map that you could put the map or location-based information on. So here you see an overview of the moving parts, the services that we need to build this web application. And if we start in the upper left, the orange is the Norwegian Public Roads Administration. So in the upper left, you have the route planner. This is not publicly available, but it is a tool for calculating the route, or several routes actually, from A to B. And then you have the datasets and the envdb. And on the right side, you have the Norwegian Mapping Authority with their place search and the land register, which we used for searching for addresses and places. We did a mashup service of those two. And the last one was the mapping layers, both aerial photographs and the raster maps. So here you have the traditional traffic announcement in text. It's sorted by road number, counties, and important mountain passes. When you open this site, it's not initially clear to you if any of these road announcements are relevant for you. So I thought I was going to show you this service. Maybe some of you already have used it. So you go to vegvesen. It's hard to see here. Yeah. For you who visit this site with the English language, this link is not present, so you have to visit it in Norwegian, and the service is pretty much meant for Norwegian at this point. So here you have the service. It's pretty much like you would expect any map. It's yeah, you could say it's inspired by Google Maps. The same behavior in several ways. You search for places, addresses. But what is different about this service is that it's data from NPRA, and yeah, they're showing it on their own map. So it's very cool. What's kind of useful here is both the traffic times, which you see here in color. You see the traffic announcements here. You see from date where you when it actually is active. And you also have, it's confusing because I have another map here, but it's not there. It's okay. So let's turn on some data points. And right here you have a menu for toggling the different kind of data layers. You have toll stations, you have road cameras, you have weather, and you also have ferries. So down here you have webcams. That's cool, nice weather. And what I like, I'm from the north, so I take a lot of ferries when I go north for vacation. And I always need to Google around for the ferry timetable. But if you click this ferry, you actually get it down here. So it's very nice, very neat. This service is in beta, as you can see here on the upper right. But it's possible to give some feedback. So I'd like you to use this service if you already haven't done that, and please give us some feedback if there's anything you would like to do better. And yeah.
All right, so let's summarize. By now, we hope that you've gotten a better understanding of what open data and intelligent transport systems is about. We've seen that there's many exciting data sets, but there's still work to be done when it comes to making some of them more easily accessible. Open data can be a driver for innovation and provide valuable, more valuable services to many type of applications. We also looked at some APIs that provide ITS data and how to get started with using them. For instance, in this map-based application, as we've just seen. We believe that we'll see more use of open data in the following, but it's important that the data owners publish their data to release this potential. We also put together a slide of resources for you to get started with. These are both links to APIs and datasets and documentation. So take a picture of it now or wait for the video to come out sometime later. Oh, yeah, sorry. Okay, one more. Okay, good. If you have any questions, we can take some now. You can also contact us on these addresses. And it's also worth noting that the Road Administration has a small unit for handling questions about data and data sets. So if any of the data sets we've been talking about here today is something that you would like to know more about, you can contact them or email or Twitter. So feel free to ask questions now or contact us later, and hope you enjoyed the talk. Thank you.
Okay, we're good.